Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm joined again by Max Beauchemin to talk about the challenges of reusability in data pipelines. So, Max, for anybody who hasn't heard your numerous past appearances, can you just give a quick refresher about who you are and how you got into data?
For sure. Well, first, thank you for having me on the show again. So I think it's been like 3 or 4 appearances, and it's been a little while since we connected. So excited to be here again. My quick self intro is so I've been doing data engineering and business intelligence for best of 2 decades now, and then I got really involved in open source while I was at Airbnb. I started Apache Airflow and Apache Superset, which became extremely popular in both cases. So for those not familiar with the tools, or Airflow is an orchestrator. So it's really about chaining up some Python workloads and running some data pipelines defined as code. And Apache Superset is an open source challenger in the Tableau, the business intelligence space. So we're competing with Tableau and Looker and Power BI. With the awesome power of open source. So that's what we do. If you haven't checked out Apache Superset in a while, or you don't know about it, so I urge people to go and check it out. The news is that open source business intelligence is super, super competitive now. There's no reason why you should be using proprietary software in that area. So if you're fed up with Looker, Tableau, or whatever it is that you use, you want to move over to open source. There's some really, really good set of tools out there. So check out Apache Superset. You can check it out on Preset. So Preset is a commercial offering. I'm the CEO and founder of Preset, which is commercial open source on top of Apache Superset. So feel free to use the open source version. But if you just want to try it, take it for a test drive, you can try Superset on preset.io. So that's the end of the commercial portion of this podcast. Let's jump into it.
And so the conversation today is around the premise that data pipelines are stuck in this phase of write everything twice, where everywhere you go, you have to keep doing the same piece of work. You can't just copy and paste from one business to another. And I'm wondering if you could just start by sharing your current thesis on the opportunities for code reuse and the shortcomings on either the tooling, ecosystem, or education that limit that code and component reusability across organizations.
Right. So I've been thinking about this for, 10 years, maybe longer. The question, since I open source Airflow, I really thought people were going to go and use Airflow or build a higher level construct on top of Airflow to share code and logic and pipeline across organization. And we really haven't seen that for a whole set of reasons that are intricate and complicated and that we're going to talk about today. Something that can be good for the listeners would be to check out the blog post I wrote on the topic. So the blog post is going to be more structured probably than this conversation, but this conversation is going to be much more interesting and exploring, the intricacies of things and getting on the next layer of talking about this challenge. But if you're curious about maybe pausing the podcast and taking a look at scanning the blog post, it's on the Preset blog. So that's at preset.io/blog. On there, you'll find the blog post that's titled "Why Data Teams Keep Reinventing the Wheel: The Struggle for Code Reuse in the Data Transformation Layer." So that's probably a good place to start our foundation, at least for this conversation. Now, assuming that some of the listeners maybe paused, took a look, came back. But the summary at a very high level is that, as a data engineer, you'll go from organization to organization and kind of rewrite essentially very similar pipelines. I think it's even more so the case for analyst engineers. So if we're talking more about the part of the workload of a data engineer that's about essentially writing a bunch of SQL or doing data transformation, like creating data sets from data sets. And typically you're going to go and take data from your CRM, your SaaS product, data around engagement and growth, on your product. You're going to be computing things like MAU, DAU, weekly active users, how many users are new, churn, resurrected, cohort analysis. Maybe you're going to go and build an A/B testing kind of compute pipeline to look at your A/B tests and your different treatments and what the p values are and how your different experiments are converging. And typically there's like just zero code reuse across organization and that layer of the data stack, which is kind of a shame, and there's probably some really good reasons for this. And there's probably some parallels to be drawn with, web frameworks, right? People will use something like Next.js or they'll use React. And the reality is that, maybe there's not that much code reuse on top of that, or CRM logic and things like that. But I think there's still the intuition that we should be able to at least, reuse a little bit of code there, create some frameworks, have some reference implementation. If not like pure framework reuse, can we have more reference implementation in the wild so that at least you can take inspiration from previous work? So that's the general kind of prompt and idea. Why doesn't that exist today? Or maybe that exists, I just don't know. I was like, give me some pointer if you know about some of these things, people, and share. Maybe there's a place for us to have a conversation around that. But there's much less that seems to exist out there than should be.
There has definitely been an overall growth in terms of the maturity and the mindset around data engineering, data integration, and movement with tools like Airbyte, your work on Airflow, the overall investment in orchestration. DBT has had a significant uptake in terms of usage, and to some approximation, that increases the productivity and the ability for smaller teams to get more work done. So to some extent, maybe there is code reuse at that tooling layer,
Mm-hmm.
but I do agree that there is a lot of rework and individual exploration that goes into, okay, now that I can pull all of my data in, where do I put it? How do I store it? How do I transform it? How do I figure out what type of dimensional modeling technique I want to use? How do I appropriately model the business? And there has been a lot of work on the software as a service or data as a service side, particularly if you're thinking in terms of the work like Segment, where you say, oh, let's just take all of your customer data, put it into our tool. We will generate the dimensions that we know how to generate, and then you'll just use that and everything will be amazing. And then maybe that works for some people, but you inevitably have to evolve it and transform it and bring it under your own control. And I'm wondering if you can talk to some of the ways that you're seeing the overall trend as far as individual and team productivity versus the amount of rework that people have to do at that more detail oriented level.
Yeah, I love that take on like the progress maybe so far over the past 5 years. So I think you're right on the data integration layer. So the layer, talk about Airbyte, talk about Fivetran. So one is open source, the other is more proprietary or SaaS service. And that layer of data integration, I think, has been solved in some ways or is getting actively solved. So that's very much, if you think about it in terms of ELT, that's the EL, right? So you just extract what's in your CRM, what's in your HR system, what's inside like whatever tool you use as a SaaS service. You can get that in your warehouse synchronized very reliably for fairly cheap, though depending on data volume, depending on I know that Fivetran and can get pretty expensive. I think Airbyte similarly, probably in terms of compute and overhead, but that's been largely solved. And maybe that's a foundation block we didn't have before that is required. Like we need some sort of universal data model, at least for the different data sources as a foundation to reuse for the T of the ELT, right? So having consistent EL is a prerequisite in some ways to having a T. We could talk about other prerequisite. You mentioned DBT, and one thing we haven't seen enough of, I think, is like the advent of reusable DBT projects, or just like reference implementation of like, hey, I built an A/B testing framework compute engine, using DBT, and here's the project, you can use it. Maybe it's parameterized. So one question around like, why haven't we seen more of these reusable DBT projects? I think I try to tackle some of that in the blog post. One is, I think, the complexity in managing different SQL dialects, right? So maybe I have a BigQuery implementation. I'm using the long tail of UDFs, or just the functions that are exposed to do some JSON processing, some more intricate, math or stats function, and then these are intricately different across dialects. And now, also then as a data engineer, I have to care about other, SQL dialects, and it's not super sexy or fun or interesting. So, and it might not be even easy to test that my want to be multi-dialect code is actually going to work on Snowflake or on Redshift or something else. So I think that's a blocker in some ways. I think SQL Mesh is kind of interesting. I don't know how good their support is for reusable parameterized projects too. There's also the issue around, if you want to do parameterized pipeline, and in my blog post, I talk about two things that are foundational. One's the idea of like some sort of universal data model that you have to dump your data into, and that might be provided by Fivetran or Airbyte as a foundation. So that's one part. But to have, say, a unified data model for healthcare data, or for CRM data, or for engagement on various products, like call it user action and time type universal model. Some are very intricate, some might be simpler, but I think that's a foundation we don't necessarily have or have adopted. I think there's been some different projects in the past to try to create these unified data models. So they may kind of exist and kind of intricate. So that's one thing. And then we need to have some sort of like parameterized pipeline. So I can say, deploy this A/B testing framework, but here's, my set of dimensions, and here's how I want to cube the data, or here's some intricacies that are specific to my business, right? So it's trying to figure out what is kind of universal and reusable, what is a constant, what is a variable. And then you would have to presumably write these what I call parametric pipelines, right? So it's like dynamically generated pipeline based on configuration around your business. I could get into some of the examples. I've got some in the blog post, but so that it's not one size fits all. We know that much. So then for the things that are not one size fits all, you need to be able to parameterize your pipeline and instantiate it. And currently, to do that in DBT, you have to write a bunch of Jinja, and that's just a pile of mess, right? To be writing something highly dynamic, like just writing code that writes SQL, is just messy by nature, right? You have a declarative language, and you're trying to bend it into being more dynamic, and it's just not what it was intended to do. So maybe the tool set is not really appropriate to make it easy for people to be like, oh, it's really easy for me to make this available for other people to use it. I'm just going to parameterize it. I'm just going to write something more dynamic, and share it as a project that people can reuse. And like, okay, there's a dialect problem. There's the messy parameterized pipeline issue, on top of other problems we could get into, but it's probably a good place to start. We're already like kind of hitting some pretty major blockers here.
Yeah, there are definitely any number of different areas that you could focus in on and spend your entire lifetime trying to improve, and people do. But I also think that it's interesting, before I get too far along this thought, there's also the case of code focused versus SQL focused, where right now we've been focused very much on the SQL oriented data engineering approach of, I load all of my data into my warehouse and then everything after that is SQL.
Mm-hmm.
There's also a significant cohort of, I load all of my data into my data lake and then I write a bunch of code to process it and do different things. And to some extent, those are converging where there's overlap, but particularly in the data lakehouse architecture or the unification of batch and streaming for different use cases. But I think also some of the challenge maybe comes in from the fact that we are typically working at least one or two layers removed from the problem that we're actually trying to solve, where we're trying to solve a problem for the business, but instead we're trying to fine tune the block size of the objects that we upload to S3 to reduce the overall latency. So there's definitely something there that I think keeps us stuck and away from being able to do a lot of reuse of the logic that is actually solving the problem we care about. And to some extent too, depending on who you talk to and where they're coming from, there's an argument to be made that the way that we're modeling the data is cumbersome and problematic, where we've been using these relational databases and relational theory to be able to try to model the business. There's a whole camp of people who say actually everything is a graph, so model it all as a graph and your life will be amazing. But then there's the problem of graph scalability problem. So I'm just wondering what your thoughts are on that juxtaposition of code versus SQL focused data engineering, and then also some of the ways that the specifics of how we think about the structure of the data is maybe hindering our ability to reuse more of these capabilities across organizational and team boundaries.
Yeah, that makes a lot of sense. I've got a lot to say here and unpack. But yeah, one thing is on the duality between say SQL and more proper coding, or not, so call it declarative to more dynamic. So, and in reality, I think today that means most like DBT versus maybe Spark, and or a data frame type API, or say like data frame group by and data frame filter. And but it does feel like writing something like a parametric pipeline in SQL it feels like like trying to do some odd things, like the equivalent of like the lamp like PHP days, where like you're doing something that works, but you're writing. I think in the PHP days, we were writing logic inside HTML files, so you'd put like an if condition within an HTML block. And then at some point we kind of flip to React, where it's more like driven by JavaScript that generates HTML. I'm not sure if the parallel is that good or interesting, but back to the SQL take. I think SQL is extremely convenient and declarative and and it's not dynamic, which makes it a lot more accessible to more people. But it's a bit of a dead end. Maybe we don't realize at which point it just kind of prevents us from thinking like software engineers, right? So it's like these declarative languages are good for fairly static things. You think like Terraform for infrastructure as code. You don't want something too dynamic there. But I think SQL in some ways, in the complexity around dialects, it's like those that like it's just like close enough, like similar enough that so that you feel like it's familiar when you switch from a dialect to another. But it's different enough, intricately different enough so that you can't really practically share code across engines. It feels like a very convenient kind of abstraction that becomes a bit of a dead end for analyst engineers to turn more software engineer, or embrace even more of the software engineering practices. And there's been a lot of like narrative around how I think bringing kind of software engineering practices to data engineering first, but even analysis or analytics engineer, but it's kind of limited to Git, right? In some ways. And there's these macros, in DBT, you can write these like Jinja macros, but God, are they nasty to write and test and debug. So that's a bit of a limitation there. It doesn't feel like DBT is the best place for code reuse. The package management just a little awkward, as a Jinja first, type thing. So there is a parallel there with PHP, probably. So there's that. Let's see, what else were you touching on? I think there was much more to unpack here.
I think some of the other interesting avenues to go through are the underlying model of the data, how we think about it. Is it all just two-dimensional arrays? Is that really all we care about? And then we say, well, actually, two dimensions isn't enough to sufficiently capture the nuance of the problem that I'm trying to solve. So let me explode this into multiple tables joined across these different attributes. that then become cumbersome to evolve and maintain, and it becomes difficult for end users to be able to figure out. So you have to pepper it with documentation and other helper functions, and maybe just hand them their spreadsheet that they actually care about. And just wondering how you see that data model that we have gotten locked into for the past, what is it, 40, 50 years now, and some of the ways that alternate storage methods, particularly in the graph space, can either
Right.
supplement or potentially at least partially replace some of the ways that we do that modeling to improve on reuse.
Yeah, I mean, let's take it from an angle of like dynamicity and data models. So if we want to do code reuse, like clearly we need part of the model to be dynamic. And I get into that in the blog post in some ways, but your customer attribute at your company are not exactly the same as my customer attribute at my company, and we care about different set of attributes. And how can we model this in relational database or traditional relational databases? It's inconvenient to have to do dynamic modeling, to be like, I'm going to alter table, add column dynamically. It's not practical to do so, and it's not reasonable to do so. So one thing I'm talking about in the blog post that's based on that premise of being in this database world, in the traditional relational database world, is could we identify these dynamic parts of the model and put them into these new, not new fields, but this emerging class of like new fields that are more dynamic in modern databases, right? So you could have, the extreme example is you have a JSON blob, and in your customer table, you would have some sort of like customer extra attributes, and in there you could have as much complexity that you want to add to enrich your customer entity with whatever is unique to your business. And maybe the framework needs something like a customer type that's like really structural and used by the framework with some assumption around, like, this is a paid customer, this is a free customer. Maybe there's some logic that attached to the customer type, and that's hard and something you got to fit into when you want to use this parametric pipeline. But then if you want to have store all sorts of other customer attributes, we would have a place for that. That's all within a column. So you wouldn't have to have this, dynamic model, or, I think the dynamic model is just not viable. Now let's do like, is a graph database or a document store or key value store a better place to, ultimately everything is kind of a keyed, everything is a document, even in a relational database, so it's all data and metadata. So whether you say create table, and define columns, or you put that in, in a marshmallow, for people familiar with the schema library in Python. So that there's all sorts of different ways that you could define a schema for your different entities, but clearly you're going to have some sort of notion of entity type and a schema for it, and an entity ID in all cases. And what, to me, whether it's modeled, in the traditional relational ways as a different physical table and a physical database, or whether it's stored, in an object store with metadata living in Git instead of, in the database engine itself, is not necessarily. I mean, it's an interesting thing to think about, but it's kind of the same problem. And then, except for maybe the properties of the different database engine and what they can do, right? So of course, in a graph database, you're going to be able to run certain types of queries in a different way. So different workloads that are like, give me all the descendants for this node, and then find all the objects. So it's going to be real good at doing that. It might not be as good at doing, full scan or a join. So that, as to like where to store it, to me is less of a challenge. But I think thinking about these parametric pipeline, what's really important is to define what is structural to the parametric pipeline and something you have to fit into, and which part of the pipeline are more dynamic, or which part of the different attributes or facts are more dynamic. So that would be like, my extra customer attribute, or my extra, transactional attribute, or the hierarchies that are specific to my business. And this would have to be parameterized and stored alongside, the instantiation of the parametric pipeline, so that we know what to do. So say if you want for the pipeline to cube the data in a certain way, and generate some count this thing group by different combination of dimension. That would be something that could be unique to your pipeline, and based on top of that metadata of the fields, that the extra fields or the extra metadata that's unique to you. So that, there's quite a bit of abstraction and complexity there. Maybe the operator of the pipeline is like, what is this thing? What does it do? Thinking about these abstractions are pretty complex is kind of an issue, right? So maybe if you're like, okay, I'm going to do my first A/B testing data compute pipeline, I'm going to use this toolkit or framework or reusable, Airflow DAG or SQL mesh, abstraction. Okay, where do I start? And then maybe you pip install this, or I don't even know, like, you dbt install the package. And then you have to start looking at the YAML configuration maybe of that pipeline and how you're going to do your own A/B testing. And you're going to have to load your data into a certain place and provide a bunch of parameters and run this thing. And maybe that interface is too complicated of a template for people. Maybe they need to go through the grind of writing the pipeline to be able to operate it down the line. I don't know, but it's quite a it's quite a complex abstraction for any data engineer to kind of inherit that and try to work with it.
I think another interesting aspect of the state that we find ourselves in is the fact that data engineering as a discipline, for one, is relatively new. I mean, people have been doing data work for a long time, but data engineering as a specific title has really only been used actively for about the past decade, give or take. And the backgrounds of people who come into data is fairly wide. There are a lot of people who come from the systems side where they start as a sysadmin, they just have to keep things up and running, and so then automatically they have to deal with the data. There are a lot of people coming from DBAs and business intelligence backgrounds. There are a lot of people coming in from data analytics backgrounds who then go further down the stack more into the pipeline management. And then
the
you also have
spreadsheet
folks.
the spreadsheet people too, like the
Yeah.
spreadsheet wizards, that realize they can have so much more impact if they work with a database. Those can be pretty impressive too as they become, data engineers. There's
Yeah.
like so many different paths and backgrounds and way to get there.
And there is also a substantial number of people with a software background, but I don't think that it's as ubiquitous as the web application development ecosystem has been, where that is purely software, has been all the way along. And I'm just wondering how you see that variance in backgrounds in the data space impacting the ways that people think about investing in reuse and those software patterns.
Yeah, maybe I'll start with an interesting parallel with front end engineering. So I think we've seen front end engineering over the past decade go from this like not so respected discipline to becoming like a true software engineering kind of legit profession almost. The perception in the past was like, oh, you're a webmaster, a web engineer, you write HTML and JavaScript, and you're not a true software engineer. Like the back end guys, the balding guys with a ponytail writing JVM code all day. They're like, okay, this guy just writes website, right? He's more closer. He's sitting closer to the graphic designers than he is than he or she is from us. But we've seen this transformation happen. It took a moment. I'm not sure exactly what are the key ingredients, that are the important milestones that allowed for that discipline to get better. If you push, and I'm deviating from the topic a little bit, but if you push the analogy and compare, and you look at code reuse on the front end, you won't see that many templates. I think what you're going to see is like frameworks and toolkits and things to abstract, like these abstractions of the CSS and HTML, and but you won't see that much. Like, here's a marketing website, right? Like I'm gonna npm install like marketing base and parameterize it to fit my marketing organization. So maybe when you get into the things that are unique to your business, like the way you treat your data or branding, on the front end, it becomes really hard to reuse code. And maybe the template approach, right? You might take a marketing website template and modify the crap out of it, but you're not going to install a marketing website package and parameterize it, right? So maybe then that points to like having a better ecosystem of templates. By that I mean like reference implementations of these different pipelines, and for organizations or data engineers to just be like, oh well, I'm working on an engagement computation framework, or I'm looking to bring my HubSpot data into my warehouse and do something with it. Well, maybe you'd use some sort of template and fork it, as opposed to take a package and parameterize it and extend it.
I think that's a useful analogy to build on as well, where in the front end ecosystem, you have these templates, you have all this tooling, but all of the work that you're doing is inherently visible because that was why you made it. You made it to show to your end users. And the way that the web is structured is that when you load it, I mean, it's getting less so now because of some of the protocol changes and the frameworks, but when you load a page, you automatically have access to all of the code that went into it to some approximation. And I think that in the data ecosystem, we're a little bit hampered by the fact that data inherently has this layer of security and shroud of secrecy applied to it. So you don't have it as visible for other people to be able to learn from. So all you have is your own past experience at other organizations to draw from, or what you're able to glean from people that you come in contact with through your own professional network and conferences, et cetera. And so I think that that also has acted as a limiting factor in terms of our ability to have these reusable templates, have this more broad reaching reference implementations to be able to draw from, because it's rare that you actually have a fully specced out data warehouse using star snowflake schema with highly maintained slowly changing dimensions, et cetera, et cetera. And so it's this more diffuse knowledge transfer than a easily referenceable way of doing anything in a concrete fashion. All we have are these abstract references of the Kimball book or the Data Vault book of this is how you do it in an abstract sense, but if
Mhm.
you want to do it in your own business, figure it out and good luck, pay me a bunch of money and maybe I'll help you.
Yeah, I like to, the one of the Kimball books was more project center. I think it was called the Data Warehouse Lifecycle Toolkit is what it was called, and that one was more like, okay, you're starting a data warehouse implementation in your organization, and how do you navigate the whole business and conduct interview and identify the key stakeholders and get to like a bus matrix. So there's a whole like recipe that probably does not work anymore. It assumes like a very waterfall type thing. It's not agile by any means. I think it predates agile, but it's more like the cookbook was kind of interesting. I like the parallel, the thing that's cool about the front end. I think you identified as it's a lot more transparent, or the code is in your face, so maybe that creates some unique dynamics to front end in some ways. Yeah, on the bringing more transparency to what's happening, or sharing more. So I wanted to bring up data gravity to this kind of an issue, right, where data is not very modular. It wants to be together and mesh together. So you want to bring everything you know about a customer inside your customer table. Actually, I have a blog post that talks about entity centric data modeling, and it says basically your dimension tables, you should think of them like like not just dimensional attributes, but bring metrics, right? So if you have a customer dimension, you have a product dimension, don't use it only for attributes of the thing. You can totally bring in metrics, like what is my number of seats sold and number of seats filled over 7 days, 28 days. So I'm arguing, kind of bring all of the properties of the entity, or as an attribute in your dimension, take snapshots, and there's a lot of good ideas there, but it points in the direction that you're going to bring all the attributes that come from all your different systems, right? So that means your CRM, your product usage, anything that's related to the customer, whichever system it comes from, you want to bring it all together. So that data gravity, I think, makes it such that data pipelines are a big tangled mess. Everything's connected with everything, and that makes it harder to say like I'm just going to share something that processes, event data, and that really doesn't touch all the other dimensions of or attributes of my customer or my user. So that's one thing. And then, there's something about sharing templates or reference implementation where I wish I could put my DBT, like we added DBT at preset, like over the years, we've grown very complex transformation layer with like maybe 300, 400 data models. And I wish I could, maybe I could just open source it, not so that people would use it, but as a reference implementation. But it's always a little shameful, and a little bit of a mess because these things grow like a big ball of duct tape. Or I don't know what exactly is the analogy, but it just kind of piles up on itself, becomes extremely complex. It feels like it's tech debt from day one. So it's not something that you're proud of. It's really hard to make something you're proud of using, templated SQL and share it in the open. Plus, there's the intricacies of the privacy, or not even the security issues would like show, like, there's probably a thing or 10, in that DBT pipeline that I wouldn't want to share, and it would be a little dangerous. I don't even know what these things are. So there's that. The shareability of these constructs is not good because the dialects, because the kind of nature of it being kind of messy and tangled up and complicated. So that's I don't think I identified that in the blog post. So it's like the self perception of the value of the code. You're like, I don't want to put that in the open. It's just dirty laundry. Keep the curtain closed, everybody.
Absolutely. For what it's worth, the code repository that I'm building for my day job, we actually do have open source. It's not necessarily a useful reference implementation, but people can look at it. But I do think that is probably one of the biggest hindrances in our ecosystem of data is, to your point, that gravity of the data, where moving it 1,000 different places to make it more componentized and modularized goes against the physics of the problem, and the fact that there is so much security layered on top of it, and the issues of privacy and just the I don't want to risk it, so just keep it under the covers. So it hinders the distribution of that knowledge. So it is much less diffuse beyond just the books that people invest in that are by nature abstract and not directly applicable without doing some of your own translation work, which is where all the complexity comes in.
Yeah, there'd be viable work to be done by someone to kind of create templates and share them as, incomplete ideals, but like reusable, and not necessarily as something you can go and run with and get value instantly from, but more maybe it's the author of a book about, practical data engineering that would be like, okay, here's an example of a DBT pipeline that computes, all the engagement growth accounting metrics that you want for your product, and here's how you would extend it. That's that stuff doesn't seem to exist. Curious on the repo that you say you opened up with your own dirty laundry, or maybe not so dirty laundry, but is that in the form of a DBT project or a Spark pipeline, or what does that look like?
So the repository right now primarily consists of some Dagster pipelines and DBT models.
Gotcha. And then you're processing what kind of is it product information or?
So it's primarily information about educational materials and how people are engaging with it. So my day job, I work at MIT in the open learning department. So it's all non-degree material for learners outside of the bounds of MIT. So not MIT students. So MOOCs, open courseware material, professional education. And so it's figuring out what are the enrollments, what are the learner engagement patterns, what are the courses that we have on offer, et cetera, and then being able to report that into the business.
That makes sense. Yeah. So that pattern, if you think of it in terms of verticals to an opportunity for reuse, So I talk about that a little bit in the blog post too, to say, what are some of the business verticals that are highly common that data engineers do over and over that where the schema in the model and maybe the customizability is not as important or as needed. Like what are some simple data model, maybe that are very simple in terms of like the input to the data model, but can be complex in terms of the output. And I think to me, it seemed like product, what I would call like user action in time, an event pipeline would be extremely useful, right? So because everyone can model some of their data as timestamp, user ID, event type, and then extra attributes, right? And if you have something like that, you can compute all sorts of actors and time, actions and times, action per user, frequency of action, click stream, like all these funnel analysis. So all from a very simple model. So maybe there's an opportunity in that area, and you've seen that a little bit productized when I was saying like there's no real reusable things that have been used in share. If you look at tools like Amplitude, or there's a lot of these like tools out there that are mostly user action, event, and time. So I could see like there's an opportunity for a pipeline there. I've been meaning to share one that is called EGAF, the Engagement Growth Accounting Framework. I have a DBT project. I don't think I've made it public, but I never felt like it was good enough to share. But I've been meaning to do this. I wanted to give a talk submitted a talk for the Coalesce conference like 2 years ago and wasn't accepted for whatever reason. So it hurt my feelings a tiny bit. And I was like, okay, I'll just do that some other time. Never got to it. But the premise with this engagement growth accounting framework was, you load your data into a well-defined, structure that's just timestamp, user ID, action or kind of event type, event subtype maybe, and some sort of extra field with other JSON you might want to use down the line. And then based on that, you kind of you parameterize the pipeline to say, I want DAU, MAU, weekly active users. I want these cohort tables. I want like maybe there's a sub module for experiment exposure, like who was part of which experiment at what point in time. So we could do some A/B testing, kind of bolt that on top of it. And it seems like it would be immediately useful to people, but it's kind of hard to get to sharing it because I wrote it maybe in BigQuery in DBT, and people couldn't use it out of the box. It's kind of hard with DBT to put a YAML file to parameterize that pipeline. I mean, it's not that hard, but it's a little bit intricate to figure out exactly what the parameters of the pipeline should be. But maybe it's an experiment to look forward to, I'm curious to try to put it out there, see if I can get, 10 or 1,000 stars or 10,000 stars on GitHub. It seems like 10,000 stars material, So every company is doing that in some capacity.
Yeah, it's definitely great to hear you suggesting to put that out there. I encourage you to do so. I'll keep an eye out for it. And I think that this conversation won't be complete without some mention of generative AI and LLMs. And I'm wondering
that's right.
what your thoughts are on the ability of this current cycle of innovation, experimentation, whatever you want to call it, how that is maybe a potential means of doing that knowledge capture and distribution that is currently done behind closed doors, and federating that a bit more, making it easier for people to say, this is the business problem I'm trying to solve. You generate the first pass at that, and then I'll fine tune it as we go.
If we want to enable intelligence in general to do great thing with reusable code and templates and frameworks, I think it's kind of the same if you're trying to enable intelligent humans or artificial intelligence. Like you need to have good docs, good reference, good naming, things that are intelligible. Humans or AI can work with. One question is, say if you put these templates out there, these frameworks out there, and they're publicly available for machine to train on as opposed to rag on, that's one thing that I really think that open source is going to get more help from AI than private source, because it's just out there, right? The models are training against Apache Superset, Apache Airflow, and they don't have access to the Power BI code base to come and help out or to answer a question or to write PRs or to answer issues. So we've seen the rise of these AI bots that are effectively trained on the superset code base, and can help us. So that in saying that maybe the AI could work very well with these reference implementation and templates, because you could say, okay, this EGAF thing I was talking about, engagement growth accounting framework, it's out there. All the butts, Claude knows about it, GPT knows about it. And when I asked it, can you help me, instantiate that in my repo? Maybe I can take you like 80-90% of the way there. Can there's question, would the AI help us get to that abstraction? Probably. Would it help us like bring this abstraction into useful or like production territory? Probably, but the more that is shared, the better, for advancement of intelligence, regardless if it's artificial or not.
Yeah, it's definitely interesting to see how generative AI has already started consuming software engineering in different capacities and how it's influencing the way people think about how they get their work done. So I'm excited to see what potential positive impact it can have on the data engineering space. And I'm just wondering, as you continue to invest in this space, try to build and promote this idea of code reuse, I'm just wondering, what are some of your hopes and predictions around that potential future?
Yeah, so a lot of hopes. I don't know how much prediction, but for me, what I do is I try to do first reflex AI for just about everything I do. So new task, new workload, new workflows, something creative, something repetitive. I always try to get the AI to help me out, and I've been having like various level of success. I gave a talk at the Airflow Summit, and at OSACon is the same talk. It's like it was around like the hype of using AI as a practitioner over the past 2 years. As a founder, as a data practitioner, over the past 2 years, I've had this AI first reflex, and then some reflection on as to like what's working, what's not working, and what I have good hopes for in the future. So there's an entire talk on that. That could be interesting. One thing I tell the people is to encourage them to have that AI first reflex for just about everything, and then give it more than just a shot of like, can you do this for me? And the AI is not helpful for that, without the context. If you try to provide more context, give it what it needs to help you out. So I think it's a critical thing to do, I think, to remain relevant. If you skip a beat or two on that, I think you can realize you're far behind pretty quickly. It's probably easy to catch up if you're behind, but really figuring out how you can team up with this kind of infinite resource, and then this thing that can really help out with a lot of things. Figure out what works, what doesn't for you. I think it's like everyone should be doing it. We shouldn't wait for the products to do it for us. Individually, I think you got to figure out how it can help you out, every day.
Are there any other aspects of this problem space that we didn't discuss yet that you want to touch on before we close out the show?
No, I think it's maybe a call out for people interested in this space. It turns out, people have been thinking about this for about 20 years too. Like when I started in business intelligence and data warehouse architecture, people were already thinking about these things. So just keeping I'd be curious if there's a way for people maybe on Twitter, LinkedIn, to start a thread if you've seen things that you think are interesting around like code reuse and how to go about it. And then maybe encouraging people to put their reference implementation out there, to be like, I've wrote an A/B testing framework or pipeline as a DBT package, as a SQL mesh project. And maybe I forked it for my own use, but here's how I got started. And here's the reference implementation. Maybe there's an opportunity to become kind of a small community around all the people that are building that specific vertical, and they can share experiences. So it's more of a sharing what you did, as opposed to like writing a framework that everyone should just pip install and use. But maybe that's another aspect of open source, and it might be a required step towards the more reusable framework. Is like, first, like, we got to look at each other's work to understand what's common and what's different, and maybe only then we can start building a framework that works for 70-80% of the people building the same thing.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And usually I ask about what you see as being the biggest gap in the tooling or technology for data management, but I think that's what we just spent the past 45
Yeah.
minutes or so talking about. So I just want to say thank you for taking the time today and for your thoughtfulness in this space and all the contributions that you've made. And I hope you enjoy the rest of your day.
Same here. Thank you for for everything you do here. I think having this medium of exchange is much better than, say, just a blog post. So the blog post is more structured, but this is a lot more interesting to really go and explore and talk about it. So I love this long form, chatty like way to approach and explore problem space. So it's been great.
Thank you for listening, and don't forget to check out our other shows. Podcast.init covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.